All right, here we're looking at section 9.3. So today our learning targets are to solve quadratic equations using square roots, and then we're going to approximate the solutions of quadratic equations. So the first thing we want to look at when we can solve a quadratic using square roots, we end up with x squared equals some constant term on the other side. So a couple things we know that when d is greater than 0, I have two real solutions. X equals plus or minus the square root of d. Because when I take the square root of a number, I have to have the positive root and the negative root. So always keep this in mind. So if I have d equal to 0, then I know that there's one real solution, and that would be x equals 0. If d is less than 0, I have no real solutions because I'm trying to take the square root of a negative number. So now let's solve this first one using square roots. So I see I have 3x squared minus 27, and I know that I want to use square roots here because I only have an x squared term. I don't have any terms with an x. So the first thing I do is I write my equation. Then I'm going to add 27 to both sides because I'm trying to isolate and solve for this x squared. Then I'm going to divide by 3 because that gets my x squared by itself, and then I take the square root of each side. And you'll see here I have my positive and my negative roots. Well, and I know the square root of 9, so I can simplify to the plus or minus 3. So my two solutions are x equals 3 and x equals negative 3. So now let's look at part B. Solve this x squared minus 10 equals negative 10 using square roots. So first I take my original equation and I'm trying to isolate or solve for this x squared. So I add 10 to both sides. Well, I see I have this x squared equals 0, so I know that x is equal to 0. So I only have one solution at 0. Now let's look at part C. So we're going to solve this quadratic using square roots. So I write my equation. I'm trying to isolate my x squared, so I subtract 11 from each side. Then I'm going to divide each side by negative 5. Well, here I've ended up with an x squared equals a negative number, so I know that I have no real solutions. And I don't have to do anything after this. I can just say there's no real solutions. So now here's a little more complicated. I've got something else with this x on the left side, but I can still use square roots to solve this. So now that this thing that's squared is all by itself on the left-hand side, I can go ahead and take the square root of each side. And again, when I take the square root, I have the positive and the negative root. So that's where my plus or minus 5 comes in. Well, and then to get x by itself, I add 1 to both sides. So I end up with 1 plus 5 and 1 minus 5. So my two solutions are 6 and negative 4. And I can double check that using my graphing calculator. Just check where my graph crosses the x-axis and see that I was right. So now here are a few that I want you to try to solve. So your goal is to solve and get x all by itself. So now here's a little more complex one that we're going to continue to solve using our square roots. Here I'm supposed to round the solutions to the nearest hundredth. Keep your eye on when we're rounding and when we want exact solutions. Okay, so the first thing I'm trying to do is get this x squared by itself. So again, I'm going to add 13 to both sides. Now I have 4x squared equals 28. Now I divide both sides by 4, so I end up with x squared equals 7. So now I'm going to take the square root of each side, so I end up with plus or minus the square root of 7. Well, the square root of 7 is not one that I know automatically, so I'm going to go ahead and use my calculator to say I have the plus or minus 2.65. So those are my two solutions. And again, I can just double check by graphing my equation and seeing where they intersect. So now here are a few that I want you to try, and you'll see here you're rounding to the nearest hundredth, so that means go ahead and use your calculator. So here's kind of a real-world solution for you, a word problem. A touch tank has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width of the tank. Well, so now I have to figure out what information I'm given and what information I need. So I know that the length is 3 times the width. So I'm going to go ahead and write L equals 3W. So now I can use that information, and that will help me find with the volume. Right? So I know that the volume is equal to length times width times height. Well, I know that the length is 3W, I know that the width is W, and I know that the height was 3 because I was told that in the original problem. So I substitute, and now I just multiply, so I end up with 9w squared equals 270. Well, I see I have a w squared, so let's get it by itself. So I divide both sides by 9, and then I have w squared equals 30. So I take the square root of each side, so I have plus or minus the square root of 30. So I know that I have a positive root and a negative root. Here I only want to look at the positive solution because we're talking a width here, we're talking a distance, a length, so I cannot have a negative value here, so I'm only going to use this positive one. So my width is the square root of 30, or approximately 5.5 feet. The length was 3 times the width, remember, so it's approximately 16.4 feet. So I can use this information to help me find the length and width. I always want to keep in mind when I need to use both of my solutions and when one of them is not actually useful at all. So here's another word problem. The area of an equilateral triangle, where all sides are the same, that's what equilateral is, with side length s, is given by this formula. A equals the square root of 3 over 4 times s squared. Solve the formula for s. Then approximate the side length of the traffic sign that has an area of 390 square inches. So I want to get s all by itself. So the first thing I do is I kind of write my formula out so I have something to work with. I multiply both sides by the reciprocal of this fraction, right? Because I'm dealing with fractions, I'm going to have to multiply by the reciprocal. So I flip it upside down. So now I have 4a over the square root of 3 equals s squared. Then I take the positive square root, and here I only care about the positive square root because we're dealing with side lengths, and I can't have a negative side length. So now that I've solved for s, I can go ahead and substitute the area that I was given and evaluate. So I just substitute that 390 for a, and then I use my calculator to get approximately 30 inches. So now here's a couple I want you to try. See if you can figure these ones out. So our learning targets today were first we had to solve quadratic equations using square roots. And you'll notice that we solve quadratic equations in many different ways, and so it's important to understand when we should use each way. When we use square roots, we always had that x squared equals something over here, right? I don't have a term with an x in it, so then I know I can use my square roots. And then I use these square roots to approximate the solutions of quadratic equations. And I can do that when I'm told to round. Oftentimes you'll be told to keep the exact answer, but when we're dealing with word problems, we're going to go ahead and approximate and use our decimal. So now that we've worked on these learning targets, go ahead and work on your homework for 9.3.